Let's have a look at part B now. So suppose that the price of a coffee is P. How many cups of coffee will the worker drink? Well, let's see. What happens here is that, again, we want to maximize utility with respect to coffee, but we have to keep in mind that this is going to affect the salary of the worker, and the salary of the worker is going to affect the utility. Now, we know that the salary of the worker is W. That's given to us, right? That is the wage. Now, what does he spend the money on? The wage is like a budget constraint, is the money that he can afford on all the possible goods. And the possible goods are coffee and everything else. So meaning that this wage is going to be divided between B, which is the consumption of other goods, plus the money spent on coffee. And the money spent on coffee is going to be all the cups that he buys for the price of P. So W equals to B plus P times C. And we can see that we have this B term, right, the consumption of other goods, into our utility function over here. Meaning that if we want to have utility in terms of coffee only, because that's what we're looking for the cups of coffee, it means that we will have to substitute B in terms of this expression, which is going to be W minus P times C, so that the utility function is going to be written in terms of coffee. Hope this makes sense. So we take this term on the other side, which is going to become B equals to W minus P times C. So with this substitution, we will write our utility function as follows. We will have the new term, which is W minus P times C, W minus P times C, and we keep going. We have minus N squared plus 2NC and minus C squared. What do we see that? What do we see now? We see the relationship between coffee and the utility. We have them in every term. So again, it's still a quadratic relationship with a negative coefficient, meaning that we're still going to find a point on the top of the graph by taking the derivative of the utility with respect to the coffee, make it equal to 0. So let's do so term by term. We're going to differentiate. Over here, the wage is a constant. Derivative with respect to coffee is just 0. Minus P times C, derivative with respect to C is going to be just the constant of minus P. Minus N squared is a constant. Derivative with respect to C is just 0. 2 times N times C, the derivative of that is just going to be the constant of 2 times N. So we'll write just 2 times N. Minus C squared, derivative with respect to C is going to become just minus 2C. Make all that equal to 0. Okay, now if we solve for C, that's what we want, we will have 2N minus P. We just write them in a different order to make it, more comfortable, equals to 2C. So this is going to be equal to 2C because we take this term to the right side. And if we divide both sides by 2, what do we get as a result? The optimal amount of coffee is going to be 2N minus P divided by 2. Let's divide every term by 2 to see what we get. 2N divided by 2 is just N minus 1 over 2 times P. So that's going to be the optimal amount of coffee. Hope this makes sense. In the next video, we go to part C.